This was the last topic that was left out in our Unit 2. We'll just have a discussion on multicast routing and then proceed further. Typically, an IP addresses refer to an individual host on a particular network. However, IP addresses accommodates the addresses that refer to the group of hosts on one or more networks also. And that addresses is called as a multicast addresses. Okay, when I discuss slowly about IP addresses in our Unit 4, we'll be discussing more about this. The process of sending packet from a source to members of a multicast group is called as multicasting. Okay, we are all familiar with our WhatsApp group, wherein we create a group, we add members to that group, we remove members from a group, we in fact exit a group. Here these things are done by people, but in a network these tasks are carried out by a router. Okay, the scenario remains the same, wherein you want to send messages to a particular group of people. Fine. So the applications of multicasting goes as this. It could be a multimedia application where a number of users tune into a video or an audio transmission from a multimedia source station. It could be a teleconferencing wherein a group of workstations form a multicast group and they receive from any member of that particular group only. It could be a database applications wherein copies of replicated file or databases are updated at the same time. Distributed computing wherein intermediate results are sent to all the participants. Most useful in real-time work group wherein you share files, you share graphics among active members in real time. Okay. Now how does this multicasting or multicast routing operates? Fine. Now all the protocols, especially you have three protocols. One is multicast OSPF, distance vector routing for multicasting, and PIM, that is protocol independent multicast. All these three schemes they use some way to create and destroy the groups and to identify which routers are the members of the group. Okay, each group is identified by a multicast address and the router knows the group to which they belong to. Fine. Now you can classify these multicast groups based upon the density. Density in the sense number of nodes in a particular group or number of participants in a particular group. If the participants are more, then such a group is called as a dense. If the participants are less, then such a group is called as sparse. So based upon the density, you decide on which type of algorithms to use. Okay. As per the definition, a group is dense if the receivers scattered over most part of the network, and it is sparse if much of the network not belonging to a particular group. Okay. Now, if the group is dense, broadcast is a better start because it efficiently sends a packet to all the parts of the network. But however, it will reach to some of the routers which are not the members of the group. So this may lead to wasteful of the resources. To overcome this, a mechanism called as purning of spanning tree is used. Okay, purning is basically eliminating or removing the nodes and links which are not a part of the group. Fine. So purning a broadcast spanning tree is removing the links that are not part of the group. And the resultant spanning tree is called as a multicast spanning tree. So if you look at the figure below, you have figure A, wherein which is a network which has both group 1 and group 2. Group 1 of multicast group and group 2 is another multicast group. You construct a spanning tree in figure B. Okay, again it has all the members of both the groups. And if you look at figure C and D, here you have only members of group 1, and in figure D you have only members of group 2. Right? So what did we do to get C and D from B? we eliminated those nodes which were not part of 1, and in D we removed those nodes which were not part of 2, right? So that is called as purning the tree, right? Now how do we burn this spanning tree? How do we remove the nodes and edges which are not part of multicast group? We make use of two algorithms, either of two. One is link state routing algorithm, as we all know, wherein a router is completely aware of the topology. It knows which host belong to which group. Okay, here every router can construct its own spanning tree for each of the senders of the group. Okay, and the protocol that is based on this approach is called as Multicast OSPF. Fine. The other way to burn a spanning tree is make use of distance vector routing algorithm. We have studied this algorithm also, wherein every router sends a vector to its neighbor. Okay, so here apart from sending the vectors, whenever a router receives the message, multicast message, and it does not have any members to receive that message, the router basically sends back its neighbor a purn message, P-U-R-N-E, purn message, telling its neighbor that it does not have any such group and henceforth do not send those messages to it. Okay, by recursively doing this, what we get is a multicast group. Fine, and the algorithm that is, the protocol that is based on this concept is called as distance vector multicast routing protocol. Clear? Fine. Now there are disadvantages of this purning mechanism, wherein we are removing the nodes and links. It's basically taxing your routers. Fine. Especially for a larger network and a larger spanning trees to be constructed, every router is supposed to store large number of multicast trees. For example, if there are n groups with average of m nodes in each of the groups, and each of these nodes wants to construct a tree, so ultimately you will have m into n trees that must be stored by a router. That means the storage capacity required will also be more. Okay, so this is overcome by core based trees, which is based on a concept of having one single tree, which is called as a shared tree. Okay, this is one thing. And one more thing, if at all your network is sparse, that means you have very less participants, not that dense, you again go with this core based trees. Okay, here all the router agree on a route which is called as a core and build the tree by sending a packet from each member to its root. Now this core, it has the information of all your multicast trees. So instead of each of the routers maintaining the multicast trees, one router which is called as a core maintains all this information, right? So the tree is union of paths traced by these packets to send to this group. Sender sends packet to the core. When the packet reaches the core, it is forwarded down to the tree. Now shared tree, obviously they measure savings in terms of storage cost, message sent and computation, and each router has to keep only one tree per group, okay, instead of maintaining M trees. So a protocol that is based on core based trees is called as protocol independent multicast, that is PIM protocol. Okay, what are the advantages of these core based trees? One is having a shared tree. Instead of having separate spanning trees, you maintain one shared tree. One more advantage is it is used for the sparse group, okay, wherein the participants are pretty less. Fine. So this ends your multicast routing. In our next discussion, we'll see with quality of services.